Hello everyone. This video will show how to evaluate logarithmic expressions. Now let's go over this first example. To evaluate this given expression, we're going to equal this whole thing to a variable, let's say x. We can go ahead and rewrite this as e raised to the power 1/2 times ln of e. And that is equal to x. This 1/2, using the power property of logarithm, can be the exponent of e, so this would come out. Now changing this to its logarithmic form, that would be ln base e of x is equal to its exponent, which is ln of e raised to the power 1/2. Please remember that this invisible base of ln is always e. Now notice that this side of the equation are equal, so that tells us that our x is e raised to the power 1/2. Or the other answer for that would be the square root of e. Now we can show a different way to do this, that is using the property that ln e is equal to 1. So we can write this as e raised to the power ln e is 1, that's over 2, is equal to x. So pretty much this is already the answer right there, or we can have square root of e as the answer for x. So this whole expression that we have right here is equal to square root of e. Now let's have another example. To determine the value for this whole expression, again, we will equal this to a variable x. What we do here is that we will use the property of exponent. We can expand this as e raised to the power ln of e times e raised to the power 3. Since that is addition, we will multiply these two together. And this whole thing is equal to x. Now we remember that ln e is equal to 1. So we go ahead and say e raised to the power 1 times e raised to the power 3 is equal to x. Since both bases are the same, we can add their exponents. So the x here would be e raised to the power 4. An alternate way to show the work for this is using the property that ln e is equal to 1. So that would be e raised to the power ln e is 1, and then we have a plus 3 is equal to x. So the answer is still the same, e raised to the power 4. Now let's have another example. So that we can evaluate this given expression right here, we can equal this whole thing to x. So that we can go ahead and change this to its exponential form, that is base e raised to the power x is equal to e raised to the power ln e. So I can go ahead and write it down here. If you notice, their bases are the same. This tells us that their exponents are also equal to each other. So we can go ahead and say that x is equal to ln e. Now, please remember that ln e is equal to 1, so that our x here is equal to 1. An alternate way to show the work for this is we got ln of e. Ln e is equal to 1, so ln e raised to the power 1 is equal to y. And so we are left with ln e raised to the power, and it was just ln e. And so ln e is equal to 1, and that is equal to y. So that means this whole expression right here is equal to 1. Now let's have another example. To determine the value for this expression right here, we will equal this whole thing to y. Now we're going to solve everything that's inside the parentheses first. We remember that ln e is equal to 1, so this whole thing will become 1, so this expression would come out. So what I did was this ln e is equal to 1, so this is pretty much like e raised to the power 1, or pretty much like e. And we remember that this ln e again is equal to 1, so we can simplify this as. So what happens here is that ln e is equal to 1, and so this is pretty much like ln e is equal to y, and we remember that ln e is equal to 1. Another alternate way to show the work for this would be Now, looking at this equation that we have here, we can change this into its exponential form. There is an invisible base e right here. So e raised to the power y is equal to the one inside the parentheses, e raised to the power 1. If you notice, both sides have the same base, so that we can go ahead and say that these two exponents here are equal each other. So we have y is equal to 1, which is pretty much the same thing as this. This tells us that this whole expression right here is equal to 1. So that is how we evaluate natural logarithmic expressions.